Okay, let's get started. So I have your quiz 3s up here. They're not in alphabetical order. That's my bad. I didn't have time. Feel free to pick them up. Please take them because you won't have another opportunity to pick them up until next Wednesday. So please pick them up. I don't really have any other announcements. I will talk a little bit about the test though. But are there any questions about, I'm guessing, assignment 4? So I guess everyone did entirely assignment 4, no problem.
No, definitely not.
So are there any questions about assignment 4? Yeah. Go ahead. Shh. Shh. Question. Yeah, so I'm noticing that too. For some students, they'll run through the combinations and then like the addition is not actually correct. So are you initializing your values, your A1, 2, whatever, as ints, or are you initializing them as longs? Okay. Can you send me your program? Yeah. 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 Don't inundate me with programs, but if there's enough of a reason why why the types are not working for some reason for some students and it is for others, I may extend the deadline because it's because everyone's having issues with that apparently. If you use longs or longs, there should be no issue. If you use doubles, there should be no issue, but we'll just have to see. Any questions otherwise, though? I'll send an announcement later today if I extend the deadline. Yeah. Great question. So who else has looked at assignment 5 yet? Okay, a few. Good. So everyone has. All right. So it asks for you to make a header and an implementation file. So remember, for the objects that we're dealing with, it's better to offload all of the work inside the object away from the business logic of the main method, right? So I'm offloading all of that work, and the best way to do that is to put it in a separate file. So I ask you to make a header file and a source file. The header file will have the class definition, and then in the implementation file, you'll put the implementation of all the functions in the header file that you define in the class. So in C-line, for example, how do you make a new header and source file? So what you do is you control-click on the class name, which is bank account in this case. We go to new, and then if you want to do both files simultaneously, which is what I recommend, do C++ class, okay? I'll click that in a second. But you could do individual files if you want to. You do not have to necessarily, in general, make a header and a source file for every object you use. Sometimes you only want a header file. Sometimes you only want an implementation, the source file. But the vast majority of the time we'll have both. So I'll click C++ class, and then ignore the stuff on the bottom. That's just to make sure that this file is also compiled in addition to the main file. So here, the name of the header and source file in assignment 5 is capital I and T.cppnh. So I'm going to make that. And then, so I push OK. And then it actually fills in a lot of stuff automatically for me. So it makes the class outer body for me. It makes the include guard, which we haven't really talked about yet, but we will today. And it also makes the CPP file over here, which also puts the include the header file of the class, because in the source file, it needs to know what functions I'm going to be implementing and what class I'm going to be working with. So that's why the include is here. But any questions on how to actually make a new file this way, a new class? It should be pretty straightforward to make a class. It's just now you got to put all the member variables and functions and all that stuff, and constructors, all that stuff. But any questions on that? Okay, so one thing that I mentioned last time is that I didn't get to work is I want to have a version string. For example, I put this version string that is the same string across all the bank accounts that I make. So if I'm running on version 1.0, for example, maybe I want to make an update, and then I say, well, the version number now is going to be 1.1. Now I want to, for example, send a message to all the people who happen to have version 1.0 and say, yeah, we have a new version available. Instead of sending the message to anyone who has the new update, I send the one to the ones who don't have it currently. So that's what static is really good for here. So the way that you did it, you initialize a static variable. So let's just make it private because unless I say otherwise, all data is private. So here, what I didn't do correctly last time was I initialized the value like this because I thought, well, if I initialize it here, that's okay. There's this rule in C++ that I don't really understand fully, that you have to initialize static variables what is called out of line. And the way you can think of this is initialize it in the constructor. So, for example, which of these two is the constructor, and how can you tell? The second one, how can you tell? Yeah, the tilde. So the tilde represents the destructor. Good. So in the constructor, I could say version equals the string 1.0. So I'm initializing it here. So anytime you make the object, the version number will be initialized to the same string, the same 1.0 string. It's not a new string. Okay? Any questions on how that works? So I was just showing what I did wrong last time. Okay, so let's get back into material. So we talked about constructors, which basically when you're creating the object, you initialize all the data appropriately. So we can have multiple constructors. For example, if we just make a square and we, yeah, go ahead.
What exactly does the destructor do?
So what does a destructor do? Can anyone tell me? I'll mention it in a second, but can anyone tell me?
Destroy?
Yeah, so when the object's about to be destroyed, it does any cleanup code that's necessary. We don't have to worry about that yet because we haven't seen the concepts for which that is warranted, but it handles the destruction of any memory that you're using so it can be freed up to the operating system when this object goes away. Because once it goes away, you're never going to need it again. So you don't need the data inside the object either. So it just handles all the cleanup stuff. Okay, but for constructors, we can have what is called the default constructor, which just default initializes all the member data to a default value, or you can change it if you wanted to. But we can also have constructors that pass in arguments. Like for a square, we can pass in the side length, and then we can initialize our data based on that value passed in. So yeah, here's the default constructor. You invoke a constructor. If you don't put parentheses, you invoke the what constructor? The default constructor. But if you put even if you put parentheses with nothing inside of them, that also invokes the default constructor. But if you put some things inside the parentheses, some arguments, that will invoke one of the other constructors. And we talked about overloading functions before, where you have to have either a different number of arguments or a different type of arguments. Those apply in the same way here. So I can overload constructors in the exact same way. Destructors, we've talked about that, is handle anything that is destroyed. You won't have to worry about that too much yet. So, okay, so sometimes we want functions to be private. Maybe if we want to do some authentication, we don't want to expose that to the user. So sometimes we want things to be private. But of course, we can not only pass in ints and doubles and things like that to functions, we can pass in other objects. Like we can, for example, make a bank account from another bank account. Maybe we're transferring some data over to another owner of the account, for example. And we don't want to have to reinitialize every single data member on our own. We want the class to handle it for us. So you can also pass objects to functions. We haven't really talked about that, though. We will once we get to arrays and things like that. Okay, so just some things about this. Here's something that's actually really interesting. If you can guarantee that the object or whatever type you pass in is never going to be changed at all, use const, because that communicates to anyone using, say, this show data function, hey, I'm never going to modify your square here. Okay, so I'm just going to pass it in. I'm not going to touch it. I'm just going to read what's inside of it. So that's obviously good for easing the programmer's mind, but what else might this be good for? Well, why might I care about this? Because if you can guarantee the values of the square will never change, then the compiler could do some optimizations there. It could run a little faster if you put const here. Why do we put a reference here in this case? We're not going to modify the object, so if I didn't put ampersand there, then I'm going to be copying the square over, so I'm not going to be modifying the original anyway. So why am I risking this by putting ampersand there? The const will fix it, but why am I still putting ampersand there? Anyone know why? What does an ampersand represent? It represents the memory location of where the square actually is. It's the reference of the object. So here, what is the cost of sending an address of memory over? Well, what is an address in general? What type is it? Is it an int or a what? It's an integer, right? So it could be a lot better for me to pass an integer over than pass this entire object over and copy all of the data over. If, for example, the object that I'm passing is an image, then it may be really expensive for me to copy the entire image over to this function. But if I copy the memory location of where it is, it's far cheaper to do that. So there's kind of a trade-off here. There's an efficiency point of view of passing the reference over, but now we have to put const on there if we're not modifying the thing. So there's something called const correctness, which basically says use const everywhere you can. So although that's not completely true, but most of the time it's true. For parameters, if you pass them in, use const and reference if you can. Yeah?
If you're allowed, if you can reference memory addresses through the names of variables, you can also directly write the memory address and then modify it.
Yeah, so the question is, can I address any memory I want to? And the answer is yes, but the operating system is going to step in and say, oh, you're trying to write to this program space. I'm not going to allow you to do that, and I'm going to crash your program for you. So the operating system tries to have some guarantee of not overwriting other memory locations, but of course the computer's dumb. It doesn't have any knowledge that, okay, this memory location belongs to some other program. It just asks the operating system, hey, can I write to this? And it says, oh, it's between this address and this address. This range belongs to another program, and so I'm not going to let you write there. But there's actually, so the announcement I made about the CPP Con talk that's happening right now, there was a talk that allowed you to write to arbitrary memory or read from arbitrary memory locations by doing some speculative analysis of how the CPU is actually going to work. So that would be a case of I can, in some cases, read from arbitrary memory. But what the operating system is trying to do is stop you from doing that. So I have the freedom of trying to do that, but it's just I might not be able to in the general case. Other questions, though? Okay, so this is also an interesting one. So I put const here in the parameter to say I'm not modifying the parameter. What do you think this const on the right side of the function means? So what this means is there's obviously no parameter passed to this function. It means that I'm not going to modify any internal members of the function. So for example, if I call getSide, I'm guaranteed to not modify the internal variable side. I'm not going to modify it, whatever this function does. So why might this be a good thing? Think of this. If you have multiple threads, which is multiple instances of this program running, and they try to access a shared square, if they try to call getSide and it's not labeled const on the right side like this, then it could be that one of them is going to access a side variable and change it, and then the other one is going to not execute in the exact same time, and so it may get different values and incorrect behavior because of this. But if I use const here, I'm guaranteed to leave the state of the square exactly the same, no matter what order I execute them. So I recommend putting const on the right side of functions if you're not modifying any internal data members. And if you try to put it there and you are modifying internal data members, the compiler will complain anyway. So I recommend doing this. But of course, we can also even return objects as well. So if I make a function called initSquare, it handles the setup and creation of a square for me. So I can create a square by calling the initSquare function, and then the initSquare function handles all of the code for me. Okay, so something that's interesting about objects is that you can what is called compose objects. So what you do here is so what this really does is try to eliminate code redundancy. So for example, if you're going to make a car class, for example, maybe you want to have some information about, say, the 4 wheels, right? Then maybe you want to make a wheel class, which handles all of the data corresponding to the wheel. So let's suppose I make the wheel class and it's all good. Now when I come back to the car class, I can have internal data members of type wheel. So I don't have to redo all of the work I did for the wheel class again in the car class. So that's what's called object composition, where I have some objects that I make, so let's say wheel, and I put them in another object that I make to build up a more complex object. So that's what's called composition. So for example, let's see. So this is obviously not true, but let's just suppose that carpets are all rectangular. Then maybe for a carpet, we need to know the length and the width. But a rectangle knows the length and the width, but not necessarily a carpet. So maybe what we can do is we make a rectangle class, and we put as an internal data member of the carpet class an object of type rectangle. And so now I can build a more complex object without having to redo code that I've done before. Okay, so this is not related to that, but this is basically what we did before. We usually put objects in their own header and CPP file. So we put the header, the main body of the class in the header file, and then the implementation of the functions in the CPP file. So that's exactly what we did before. So what happens though, so remember when we were talking about IOStream way back when, and for some functions we needed to include the string header, and we saw that all we needed to do was include the IOStream header. So why was that true? So why did I not have to re-include string? Yeah.
String is included in IO.
Right. So when I include IOStream, I inherit all of the includes that it includes, and string is an example of that. So the issue is, if we make this car class or int class or whatever, and I include it multiple times in the same file, like the main CPP file, then the issue may be that you're trying to include this multiple times and the compiler will complain at you. But if you do what is called an include guard, then what this says is if you've not defined this class before, I'm going to define it now. But if you have, say, included it before, then I'm not going to redo it, do it again because I've already included it. And the way this works is you put some symbol name here. So the first part of this says if ndef, which means if not defined. So symbol name here is if this symbol name happens to not have been defined before, now we're going to define it here. Okay? So it's just kind of a roundabout way of saying we will only include this thing one time. Okay? So we define it here, then we put anything we want in the header file, usually a class, and then at the very end we put a end if. By the way, what is the pound sign here? What does it correspond to? The preprocessor, yeah. So this is the work, again, of the preprocessor. We saw this with hashtag include. Now we see it with hashtag if and def. Yeah. So good question. I haven't tested this, but let's see. So let's say that I'm going to put this, I'm going to be a good programmer, and I'm going to put the blank account class in the, I guess it's in the int class. So I'm just going to put it in here. Notice it says errors for string and cout. Why is that the case? Yeah, it's not included here. So I need to include IOStream to make it work. So include IOStream. And then here, what I'm going to do is I'm going to now include our bank account class. But here, the angle brackets on the include for the header file, that means it's what is called a system header file. So IOStream and string are a system file. But now we've defined our int header file and int CPP file. So those are what are called user-defined headers. And then you put those in double quotes instead of angle brackets. So here I put int.h. And then, maybe it will work. Yeah. No. Okay, yeah, actually, yeah, you're exactly right. I'm so used to not doing that that I forget sometimes. Okay, let's try this. Yeah, so this is actually one of the weird things of C++. You get this weird error that says symbols not found for architecture whatever. Does it say anything like, okay, you dummy, you included this thing twice by accident. So what happened here? Actually, that's weird. So I have an if and def here, but it doesn't have an issue. Let's see if I do this. Huh. I didn't expect that to happen. Okay, so yeah, so I have the if and def here, that's fine. So that's not an error. So if I see an error like this, what is the best thing to do? Google it. So although I know I've Googled this thing so many times, so I know what's going to happen. It's not going to give me the answer I want. But okay, yeah, that's not the one I want. Yeah, so it's usually because I included something twice instead of once, but I actually don't see the error here. I will look into it. But this should work. So I'm not trying to fool you or something. But any questions on my failed demo? You had a question?
You use that and down there as well.
Well, I think my CMake list has it. Yeah, it has the executable stuff in there. I'll look into it. But I mean, it should run. Let's see. So if I comment these out, it should be okay. Yeah, because it just optimizes it away. I didn't expect that to happen. I'll look into it. But it should be because I wanted to show that it doesn't work if you don't have the include guard here, but in fact you actually do. Because if I do this, it shouldn't actually do anything different. Yeah, okay, I'll look into it. But any questions on what it should be, what the include guard is meant to be used for? It's just to prevent multiple includes of the same symbol name in this case, but really it's including the same header file twice. Okay, so yeah, so the reason we have the header and the CPP file is mainly to separate what you're defining the class to do and the actual implementation of the functions. So instead of just thinking about the object from outside perspective, now we're inside the class and we need to think, well, how should we separate the things that we're defining the class to do and how it actually does them? So that's what the header file is for, to show the user what we're defining in the class, and the CPP file is to specify, hey, this is what the functions actually do in the class. But any questions on classes in general? Yeah, I'm going to look into that because that is weird. So maybe let's try removing these. So maybe I'm just going to copy this out just in case. And then I'm going to delete this. And then here, I'm deleting this. And then let's make a new class. Yeah. So let's make a bank account class, although this shouldn't matter. And then, okay, now it's falling apart on me. No. Okay, finally caught up, or not. Let's see if it actually works. Anyone have a hypothesis as to why? Because I'm not used to seeing something like this. Yeah, a claim might be correct here. Let's see. So let's include IO stream again, and then let me try something. So let's I don't know why I did that, but yeah, sorry about this. I'm not used to demos failing this often. Let's include our bank account class. So it resolved that. Okay. Oh, okay. It might be because of this. Let's try it. Okay, yeah, that's different. Okay, yeah. So it must be something to do with that static data member. I'm not sure why. Yeah, so static is a weird thing. But so this is exactly what I wanted to show here. That so it does work. It's something weird to do with static, so don't worry too much about static here. But yeah, so here's what you put in the bank account header. But of course, in this header, I have the implementations of all the functions here. So what should I do to be more aligned with object-oriented programming here with respect to the implementation of the functions? I should put the implementations, remember, in the CPP file and just put the prototype of the function in the header, saying this function's here, but what the implementation of the function is in the CPP file. So I'll just show you one example of this. So what we could do is remove this withdraw function from the header, and I'm going to put it right here in the CPP file. I'm going to change the header version to be the prototype. So here, the semicolon at the end means it's just a prototype. I'm not actually implementing the function right here. But what do I need to do in the CPP file? Well, does this CPP file know, yeah, this withdraw function belongs to the bank account class? No, so what should I do? Yeah.
Use the scope resolution operator.
You remembered, good. So I need the scope resolution operator, so someone else, what is the scope resolution operator? Yes, colon, colon. Good. So here, we need to specify with the double colon to say, yeah, this function really belongs to the bank account class. And that's why it says, oh, I don't know what this balance variable is because it doesn't have access to the bank account class. So let's make a bank account scope here, so that now everything's hunky-dory. So it says now the bank account class has this function called withdraw, and it happens to be this version of the withdraw function, and here's the implementation of that function. Okay? Any questions on how that works? Okay, so it should be relatively simple. So it's just, most of the time you put the implementation of the function in the CPP file, and you put the what in the header file. I mentioned it already. Prototype, good. So the prototype, remember, is just everything about the function with a semicolon, but without the implementation of the function. So it's just the return type, name, and any parameters you pass. Right, so that's actually something really interesting about classes. It doesn't actually matter what order you define the functions or variables for that matter in the class. So I could put this withdraw thing down here if I wanted to. And for example, deposit for whatever reason could access the withdraw method, even though the withdraw method is defined below. So that's the weird thing about classes, that you can define anything anywhere inside a class. It doesn't matter what the order is. But if you're defining normal functions, the order actually does matter. Unless you put prototypes at the top, in which case it actually doesn't matter again. Good question, I didn't think of that.
At the top of your file, with your, why do you have it built in?
So these only correspond to this symbol name. So it has nothing to do with the bank account class. So what this means is, if this, whatever it is, called a symbol name, is not defined yet, meaning it hasn't been seen yet before, now we're going to define it right now. Okay? So that's what the # define is for here. But then maybe we include this again somewhere, in maybe some other file. Then we come across the if and def statement again and say, oh, but this thing's already defined. I'm not going to redefine it. So now we avoid the issue of having to include this thing multiple times. I only need to do it once. Yeah?
But you need define with and that. So you need to
I actually could, for example, do this, and it won't actually do anything, I don't think. So if I tried to do this, I don't think it'll actually do anything. Because let's think about how it works. The if and def says, if this thing's not defined yet, then we'll include the class all the way through. And then we come back and we say, well, it's still not defined, so we're going to re-include it again. So then if we include this by accident multiple times, then we'll have an issue there. Any other questions? Okay, yeah.
So you have the if indefinites in all caps, and then you have like the underscore for the spaces.
Yeah.
So why, when you include it in your CPP file, does it not look like that? Like, does it count?
So here I'm including the file name. I'm not including the symbol. So a good question. So remember the includes on like IOStream string or whatever we want? Those are the file names. So we're including the file. Here is the symbol name, which exists outside of the file name. So if, for example, I can call this Fred if I wanted to. And it would make absolutely no difference. It has nothing to do with the name of the file. It's just a handy name to denote, hey, this corresponds to bank account. But I can call that whatever I want. Other questions? Okay, so I have other slides about this thing called the structure. So structs are not on the test, so don't worry about that. And I'm actually only going to talk about these today. I'm not going to get to all the slides, and so I'm not really going to test them. So well, why do I have so many slides and I'm not going to test them? So the reason why structs exist is a backwards compatibility thing. So remember C++? The original C language had this thing called structs, but no classes. Sad world. So a struct in C++ is almost identical to a class in every way other than the name. So there's only one difference in, between a struct and a class. So all of the things that carry over from classes go to structs as well. So that's the main reason why I won't teach it, why I won't really test it. But the reason why they're different is that what is the visibility of variables by default in a class? Are they public by default or private by default? Private by default. What do you think they are for structs? Public by default. So structs are public by default and classes are private by default. But of course I can put private and public in there and I can do exactly the same thing in either case. So I can make objects and structs exactly the same way, no difference. It's called struct or object. But if you want all things public first, then you should probably use a struct, but it actually doesn't actually matter. Okay? Any questions about that? Yeah, so you can do exactly the same thing as before. There's literally no difference other than the name of the thing. Okay? So we'll talk about the last bit of slides briefly, but I want to talk about the test a little bit. So let's look at the test. Well, not the test, but the review. So any questions about the test itself? So when is it? Friday. Should you come early or right at 8:35? Early. So I'm going to give a comprehensive email to the TAs of how to lay out the tests. I'm going to give them precise orders of what to do because I'm giving a conference presentation, and I'm not kidding. The time the presentation is literally when the test is. So they can't even email me and ask me, they're asking this, what should I do? So, and that's not my fault. So what you should do is, if you have any assumptions at all, you could ask the TAs, but if you don't want to ask the TAs for whatever reason, write down your assumption and continue under that assumption. I'm going to try to make it bulletproof for assumptions, but maybe something will slip through. So try to think, you're trying to communicate to me that you understand this concept, but this thing seemed ambiguous to you, so you're going to make an assumption. So make an assumption and move on. But any questions about the test? Yeah.
Can you give us any direction as to like what we should know for response?
Yeah, so what should you know about this? Well, really everything. But what are the three main things that cover these chapters? Yeah, so functions, loops, and classes, right? So you should expect two of those three to appear. And what is the one that seems like it could be in either one of the two? Well, functions can be in classes, right? And where could for loops, or say loops in general, be? Could they be in functions? Yes. Yeah, could they be in classes as well? Yes. Yeah, because functions can be in classes. So think about that sort of thing. So I'm trying to test everything equally so that not one thing is tested much more than another, but I've tried to make this as uniform as possible. Okay, so you should know loops, you should know functions, you should know classes. Okay? Any other questions about the test? Yeah.
So will tests just be laid out by alphabetical, or will you
Yeah, so there's no more seating chart. I made an announcement about that because I can't trust the one that the department gives me. So they will be laid out alphabetically, for sure, unless the TAs secretly tried to underdo me or whatever. But I'm giving the test in alphabetical order to the TAs, and your name will be on one test. So yeah, so please come early, try to find your test, and hopefully it won't be too bad. So remember, what could you bring to the test? Yeah, cheat sheet of? Handwriting, yeah. So because I want you to learn the material versus just type it up and you won't learn it as much. Okay? Hopefully it shouldn't be, there shouldn't be anything surprising about the test. We've gone over everything that you need. You won't be asked to do anything that you haven't seen before. It's just of course, the problem you haven't seen before, but there's no like new concepts or anything. So it should be fairly straightforward. But any other questions about the test? Yeah.
Just confirm, like, the cheat sheet could be 8, 11, both sides?
Yeah. So my rule is any size you want. I don't actually care as long as you don't disturb the person next to you, on either side of you, I guess. But yeah, because I want you to have to think about what things are important, but I don't want you to necessarily constrain you to a certain size. But I mean, I've done handwritten 8x11 sheets of paper before, and I hate writing in microscopic font on two sides. It takes so long. So try to think about what are the important things that you think you won't be able to remember during the test. Okay? Yeah. Other questions? Yeah.
Is it possible, I have a question about one of the topics that I didn't really understand.
Yeah, sure. We have like 6.5 minutes. Yeah.
Can you go and ask the data by value by reference?
Yeah, absolutely. Great question. So let's go back to object. Yeah, functions, I think. I'll have to see it's in here. Yeah, so as I said before, and I still believe this, these two slides are the most important things about C++ at all. So the question that was raised was, what's the difference between passing something by value and something by reference? So can anyone give me a short explanation of like what the difference is? Yeah.
Casting a value is basically that you cannot change the original value of what you get, and by references you can modify it whenever you.
Right. So the upshot of all of this is passing by value, you can't modify the original, and by reference you can. So how does the program actually achieve you can't modify the original? How does it achieve that? Yeah. It makes a complete independent copy. Okay? So the by value case is when it just makes a complete separate copy and it can't modify the original because it's an independent copy. But by reference, you pass in the memory location of where that object lives, And so it's the same object you're going to be dealing with. Okay, so I can actually show you this. So let's see. So let's go back to CLion, ignore Fred. So let's just do IOStream for instance, ignore bank account. And then let's just make a function. So let's just say void function, and let's just say it passes a parameter x. And then let's just say we do x times equals 2, so multiply by 2. And then we make a different function. Let's call it the same. I think that'll work, yeah. So let's just say that we initialize x to be 5, and then, actually I'll make this fun too to differentiate it. So let's just say we see out fun of x with a new line, and then let's just do fun2 of x with new line. Actually I should do int in this case. Yeah, that's the reason why. Okay, so let's do a return in both of these. So here I'm going to be passing in the data, multiply by 2, return x. And then here I pass the thing by reference. It's exactly the same otherwise, but I pass it by reference. So what should the output of these two functions be? Well, step through it. X is 5. I pass x into fun. So what is the value of this x right here? 5, right? So multiply by 2 is 10, and then what do I return? 10, good. So what should be printed on this first line? 10, good. What about this one? So when I get down to this point right here, so what is the value of x right here? You sure? It's still 5. Why? It's passed by value in the first function. Okay, so I'm not modifying the original x, I'm modifying the copy when it's passed into the function. So x is 5 right here. So when I go to fun2, what am I still returning? 10, right? So I'm passing in the value 5, the address of a variable which has value 5. I multiply by 2 of the original x. And so what is the value of x now? Don't think about what I return. What is the value of the original x? It's now 10, but I'm still returning 10. So in fact, if I run these two, it'll print the exact same value, and it does. But exactly, great point. So if I flip these around, what should I be printing? 10 and 20, and in fact, we do. Okay? So you notice that there's no difference here. What if I put a comma in between and say, okay, now it's going to quit on me at the last minute. Okay, come on. So here, what I want to show you is that CLion is a pain, I guess. So I wanted to do something like this. So I print fun of x as well as the value of x. What should I be printing? Well, 10's in the fun part, but what about the x's? 5 and 10. Because remember, I'm not modifying the original x in the first line, but I am in the second. And in fact, that's what we see. Any questions otherwise on how this works? Or any other questions about material, things like that? Yeah.
Really quickly about programming.
Yeah, sure.
So for the problem 2, the displaying the number of parameters, how do you handle
How do you handle the?
negative integers?
Well, odds are just the same thing as negative in the negative case. Yeah. So it's like -1, -3, -5, -7, that sort of thing. So the loop should be identical in both cases. Other questions? Okay, so I'm not going to see you on Friday. And Monday is fall break. So I will see you on Wednesday.